an F list, and a G list. And what you need to understand about this is whenever they give you things in lists like this, these ordered pairs, we used to talk about ordered pairs where we would say, oh, I have an X and a Y value, right? But now, since we're advanced, we talk about it a little bit differently. We talk about it as X and F of X. Because remember, F of X means the same thing as Y. So as I look in my list, just to use one example, the X thing that we're talking about is the first number. And the Y thing that we're talking about is the second number. Or in other words, if I'm looking at the very first thing here, this 5, 0 is saying F of 5 equals 0. That's what it means. So now I go look down below. And the crazy thing is about these questions, it's like a puzzle or a maze. So I look at the first part, right here, G of 4, because I always start with the inside. So I look for G of 4. G of 4 means go on the G list and look for the X being 4. I go over here and I look in the G list and oh look, there's the 4. So what is G of 4? Negative 1. So now what I'm saying is I really want F of negative 1. Now I go look in the F list for negative 1. Oh, there it is. So F of negative 1 is 1. This thing was my G of 4. So it's like tracing a path. Let's try another one. Oh, sorry.
So for
What I should have done is I should have said, oh, G of 4 equals negative 1. So now I see that my G of 4 that was on the inside is negative 1. So where I saw G of 4, I now just put a negative 1.
oh yeah.
And now I want F of negative 1. So now I only look in the F list. Was that your question or no?
Kind of, but yeah.
Are you sure or no? Okay. Let's try another one. I mean, I know this is kind of tricky, so let's try another one. Let's look at F of negative 3. So I start with the inside stuff in part B, F of negative 3. And when I look for F of negative 3, I see that F of negative 3, I go to the F thing and oh look, there's negative 3. So F of negative 3 is 4. So I'm done. That's F of negative 3. But I don't want F of negative 3. I really want G of F of negative 3. So that's telling me I really want G of 4. Because whatever I found, I shove in there now. So now I go to the 4 for the G, and it's, negative 1 again. Yeah, because G of 4 was negative 1 the first time also. Yep. All right, so I'm going to do one more for you, and then this one, what's the difference between C as compared to the first two? This has got more. This is doing this more often. So it's not different, it's just more. So it's 3 things instead of 2. So let's look at the F of 5. So F of 5 is 0. But I don't want F of 5, I want G of F of 5. So now I go to G of 0. And G of 0 is negative 2. And then, oh darn it, I didn't want that. I really wanted F of negative 2, which is, thank you. That's my answer, 6. Okay, you guys try one and compare. You got 60 seconds. Okay, so thank you for doing that. Good job. In this last problem, they use a word problem. So the kind of nice thing about our class is oftentimes we can come up with some kind of real life example. As you get higher and higher in math, it's more difficult to find those. What I want you to do is I want you to read number 3 And I'm going to see if we can get most of this in, if not all of it in, before lunch. So read number 3. Okay, I just really wanted to get started. So Jennifer and Pam go to the snack shack, and they each have 50-cent coupon. And it's for a $5.49 value meal. If they show their ID card, they get 10%. Jennifer's server rang it up as the value meal and then took off the coupon. And Pam did it the other way around. And what we're going to see is what happens. So, let's talk about them separately here. First of all, there's Jennifer. And Jennifer's server rang up the value meal, then took off the coupon. And Pam did the value meal and then the coupon. Oh no, sorry. I forgot to say that Jennifer took off the discount for the student ID second. So the coupon was last in the blue, but first in the red. Okay, so let's look at how much each girl paid. Let's look at Jennifer first. So for Jennifer, she started out with $5.49. And what did she take off first? 10%? 50 cents first?
Yes.
Okay, so we take off 50 cents first, which means she would be at, so this is the coupon, so she'd be at $4.99. Is that right? And then she took off 10%, right? Which is 0.499, or in essence, it's still 50 cents. So if you take off 50 cents, the end result is $4.49. Because 0.499. And the second person, Pam, started with $5.49 and then took off $54.9, which really is the same as 55 cents. If we go to the nearest penny. So if you take off 55 cents, she's at $4.94. And then she's going to take off the 50-cent coupon, right? Which is a total of $4.44. Who got the better deal? Pam. Pam got the better deal because of how they rung it up. It's kind of important to understand. This is really not like major algebra skills, but when you go shopping, you should kind of know those things. Now, what I'm going to do is I'm going to stop there. So in the next few questions, they ask some stuff pertaining to these types of problems. In the first one, they say to write a function, and they're talking about like cost maybe or something, that deducts 50 cents from a price. Looks really confusing, but really all they're saying is, if you talk about this C of x thing, your price is x, and you want to take off 50 cents. So this is what they're talking about. When they talk about the d of x function, what they're talking about is that you want to deduct 10% of a price. So in d of x, really what's happening is you have your x that you start with, and then you take away 10% of that x. And I wouldn't write it this way, of course. I would simplify it. I would call it 0.90x or 0.9x. And what they want to do is they want you to understand what's happening when you shove one of these functions into the other function. So they ask the questions c of d of x and which server has this, because they want to see what's going on. And what I want to remind you is whatever you see on the inside is what you do first. So as I look at what's on the inside, what I notice is that the d of x function is on the inside. So that's saying, look at this 0.90x, the d of x thing, and you're going to shove that into the c function, which is over here. And when you shove that into the function, you're supposed to see what ends up happening for that. So c of d of x is really saying something like, I want c of, and shove in the 0.90x. And what you get when you shove that in is you get the function up above, which was the whatever I was having minus 50 cents. And what I shoved in was the 0.90x. So that's my information with that. If I have the c of d of x, 0.90x minus 0.50, or I could have written it if I wanted to, if I want to make it look a little bit nicer, 0.9x minus 0.5. That's another way to say it. And they're asking which server had that. And that was, when we were looking at it, that was Pam. She had the better deal. And so Pam had this. And is there a price for this value meal that will result in the girls paying the same price? So we know what Pam's thing looks like when we do the composition of functions. Probably what I should also do is I should also look at what Jennifer had. So if I look at Jennifer's, hers would be in the reverse order. Or in other words, instead of being the c of d of x, it would be the d of c of x. So if I look at d of c of x, what this means is this time I'm going to put the c of x stuff in the d function. And so when I do that, what I'm saying then is that the d function, which was 0.9 times whatever the x was, and the x was whatever I was shoving in, which was the c function, which was x minus 0.50. And then I simplify that. So 0.9 times x is 0.90x, like I had. And then 0.9 times negative 0.5 is negative 0.45. And what the big question is the stuff that I see here for Jennifer ever possible to be the same as the stuff that I see here for Pam? And the answer is no. They can never be the same, because if you look at them, what you'll notice is they both have the 0.90x's, but one is taking off 45 cents and one is taking off the 50 cents. So no, they will never be the same.